we still need to rely on some measurement. Like if we show that sport is good for well-being, we need some measurement of this. And this is getting even more important because there is this idea, and actually I got this quote is actually coming from many different people. I don't know exactly who said it first, but it's already in our culture, and it's the fact that everything that can be measured can be improved. Sometimes you have different versions, like if you cannot measure it, you cannot improve it, but the concept is the same. We need measurements to determine what we can improve.
In doubt, it was always advertised.
Yes. And because actually, if you think also of what maximization is, it's pretty much that you want to find some way to increase a specific value, the value that you are measuring. And so in today's presentation, we say like, okay, this paradigm is getting stronger and stronger, eventually might lead to very wonderful society, or maybe not. We had a lot of discussion on the implications of this. But at least the thing is, at least the measurements that people are using for good or for evil are at least good. And so today I will discuss about this. And first of all, I want to see what
It's if you open page.
I think I open it.
Okay, you're right. Okay. Oh, no, but it's here. It's in the.
Okay, I have it in the other screen.
You need to drag. Yeah.
Okay, so it's an interesting distribution, and so we can discuss it more in details later. In any case, what we can see is that most people, at least in this room, and actually I had a poll on Twitter some weeks ago, and I had very similar results. Most people think that there are some problems with measurements, they're far from perfect, but in some way, we can still use them. Still makes sense to use them. They can give us some results. They're far from perfect, but there's some way like they get the job done. So I can go back to. Oh, like down here. Is it? No, I can reopen the presentation here. Or I can close this. Yes. Yeah. Okay, so Rocket coming back. So yes, as I was mentioning, also like I had asked this on Twitter some days ago. You know, now Twitter is the new platform for democracy, apparently. So. So yes, most people still like think that some way we have some problems, but we can solve them. Here, I also want to specify something because many times when I discuss about this, I'm always together with some arguments which are very similar to the one that I'm bringing, and it's the fact that people know that arguments are bad, but some people then make a jump and say like, if arguments are flooded, then we should never use them, or like you should only use qualitative, or like go somewhere like to the other extreme. And this is also why I actually presented the pool with the two options in between, because I really want to stress out that we can have something which is flooded, but still it can have some very big value to our society. Doesn't mean that it needs to be perfect. And actually there is a very good example, because physics and engineering, like measurements in physics and engineering, are not perfect. We have measurement error, we have the uncertainty principle. So we have like a basic principle that tells us that our measurement cannot get better than a certain limit. Of course, I'm simplifying a lot. Even like regarding theory, because a lot of the criticism of measurements is about the theory of measurements. In theory, in physics, we had things like the Dirac delta function that when appeared for the first time, it was horrible because it didn't make any sense. But people knew some way like how to use it, even if it was like the massive problems in theory in using the Dirac delta function. And still like they got some amazing results. Indeed, actually, despite all the limitations of measurements, we still were able to send people to the moon. We're able to create like devices which make like super powerful calculation. And this is with all the flow that the limitations that we have with measurements. Even better, and maybe Javier might like this slide. Oh. This is actually a construction from my area, and is some towers which were built like thousands of years ago. Nobody knows exactly what these towers were built for, because people at the time they didn't know how to write. So they didn't. So I think it's reasonable to say they didn't have a strong theory of construction. They knew how to do things, but probably they didn't have like a very strong coherent theory. So all of this is to say that we know measurements are problematic, but eventually we might still have that they get the job done. So today I'm actually going to show you with some examples from the literature that actually we have like a very big problem when we using measurements, and we get some very weird results. So we know there is a problem with theory, but actually even worse, there is a problem with practice. One of the main biggest problem at the moment is that the way we use this measurement at the moment is that we get data and then we extract the measurement. And then we trust the measurement. So we cannot really question the quality of the measurements because we don't really have anything to compare to. For example, like if we're measuring opinions of people, we just make the survey, we check if the survey is well constructed, but then that measurement is actually what we believe. We say like the population has this distribution. These people think that they are more Republican than Democrat, for example, or whatever. So we don't really have a strong way to validate measurement most of the times. But there is a way actually to check if they're producing some good results. And the idea is, if we start from the same data and we try to access the same measurement, for example, political opinion or happiness or trust, whatever we want to measure. If we get results which are very different from each other, even if we're using exactly the same data, the same population, everything, then we know that there is a problem with measurements, because what are we measuring? If the same person might be very smart in one measurement system, but very stupid eventually, like in the other measurement system. Our measurement is flawed. So I will show you some examples from the literature. Fun example is actually, for example, this article in which they took some other publications and they started verifying what was going on with the tests. And they check if they could reverse, for example, the results of the test just by applying some simple rules, like, for example, the fact that the data were ordinal. And for example, in this publication, what they showed was that they were able to reverse the result of 47 out of 48 tests, which means that 47 of the 48 conclusions eventually might be completely reversed just by measuring the same thing in a slightly different way. Another publication, this one probably is my favorite one for showing this problem. They asked several groups of scientists to test for the same hypothesis. But the problem is the following: if we ask like many different scientists to test for the same hypothesis, everyone would get a different sample. So we would get like a distribution, we would have some which are positive, some which are negative, just to statistical fluctuations. So the authors of this experiment, they had an idea, and it was like, instead of asking everyone to recollect the sample, we give the same data set to everyone. So instead of getting a distribution like this, we should have that everyone should get exactly the same result, because you have the same data set, the same population, and the same tested, the same hypothesis that is tested. So everyone should get the same result. The result of these studies actually were pretty shocking to me, because what they obtained is that almost 60% of people, of the researchers, got like null results. So they didn't find significant effect. 25% found statistically significantly negative, and 17 statistically significantly positive. And this statistically significant is from the same data set, the same people, the same everything. So the only thing that changed here was that how people manage the data set to actually extract the measurement and test for their hypothesis. So just this degree of freedom can completely change the result. But now you can think that if only one of these people actually run the test, maybe they will get a significantly positive. This will be a publication. And this is like knowledge that we use for future research, for making decisions, for a lot of things. So it's just due to like this, how the measurement is actually constructed. Okay, but a lot of this was with very simple tests. So how do more complex models deal with this uncertainty? I've been working on this, especially on agent-based models, and seeing like how agent-based models and especially opinion dynamics models change if we change the way we measure opinions. And here you can see, for example, the simulation of the same model on the same population, same parameters, but just changing the way the measurement is built. And if you see like the model running, it gives you like completely different dynamics. And even the results are qualitative different. It's not like you have some quantitative difference. Like it's different to a qualitative point. If you use the first measurement, you would say that the population will converge some way to agreement. Everyone is going to the same opinion. If you use the other measurement, you will say that the population is polarizing. So it's completely different result to a qualitative point. And for example, we also tested with like a data set and started like trying to make predictions, for example, if people would trust or not trust science. And again, from the same data set, you can get both one result or the other, just the way you process the data and how you conceptualize trust pretty much. And also, like, you don't need to use just very fancy method. Here, it just depends on which questions, for example, you're selecting. So the general idea, there are actually two main paradigms in the social sciences. There are some people which tend to have this idea that there are some measurements and we can access them. For example, there is intelligence. There is you can measure intelligence. We are limited. There's some measurement error, but we can improve and get better and better to measure something called intelligence. Other people, and yes, actually, you can also, like, for example, in psychology, there are a lot of ways to actually improve the measurement and some way converge to the real value. Alternative approaches say that maybe like there is not a thing called intelligence or opinion or whatever, but still like people behave in such a way that we can summarize everything as a single measurement. But what evidences are showing is that in general, when we try to measure one specific feature of human behavior, for example, we have so many degrees of freedom that in many cases, not in all cases, but in many cases, we can get like completely random results. And if you want to see this a little better, like with an example, there is a simple way to visualize how this confusion, how this freedom, some way in the choice comes to be. Because if, for example, we want to measure the height of these three objects, we would say like this is the shortest, this is the tallest, there is no doubt on this. But if now we want to measure, for example, the height of this object, we have some freedom. So some researchers would say it's just like this height, and some researchers might say like, oh, maybe you should rotate the object. It makes more sense to me to rotate it. And some else would say like, no, to me it makes more sense to just leave it flat. But these choices actually are done with the idea of operationalization. And so when you want to measure something, you need to make a series of choices, of practical choices, which bring you from the general idea of height or opinion, happiness, whatever, to the actual practical measurement. And so this means that, in general, some people might choose one operationalization or the other. But in some cases, you can have that the results can completely change depending on your measurement system. Because these three objects, for example, would be ranked as the tallest and the shortest in one measurement system, and exactly the opposite in the other measurement system. So the problem is that still, when I'm presenting like some of these results, sometimes people say like, okay, but which one is the right one? For example, if there are two measurements of opinions, they're completely different, at least one of them needs to be wrong, right? The problem is, as we just saw, no, they might be both correct because both measurements are measuring height. But the problem is the way we measure has so many degrees of freedoms that in some cases it can generate very wide results. And yeah, as mentioned, for like practical measurements, what we have is that we have so many degrees of freedom, because if we want to measure something like opinions, we have to choose the questions. We have to use how we present the choices, because we can have a Likert scale, you know, from agree to disagree. We can choose how many levels we have, maybe like 5 levels, 7 levels. We can use a slider, and even the question, just the way you phrase it, it can completely change where people will put themselves. And so the general idea is that some way we used to think that measurements, and so like also all the decision or all the results we get from measurements, are mostly based on the construct we are measuring, for example, opinion, plus some additional noise. What we're seeing is that in many cases, we are mostly measuring just the operationalization process. And so just how we decided to measure that thing without really having information on the real construct. I want to conclude with how to solve it with, okay, actually, I'm pretty much done. We still like, there are still many ways to explore this, but it's very open to discussion and to exploration. But of course, like many people suggest using qualitative approach. One of the problem with qualitative is that some way like it didn't manage some way to convince people so far. We have an explosion now of data and new tools. So I'm not really sure if like keeping pushing for qualitative will really convince people. Alternative ways are, for example, really trying to test for example, ordinality transformation. This is actually available, but pretty much nobody is doing. And the other thing, and this actually connects also to a lot of what we discussed today, is trying to go for the multidimensionality of measurements. So instead of relying on a single measurement, we can actually test many different operationalization. And if we see that, I don't know, sport has an impact on well-being in many different dimensions of well-being, then actually it's going to be a valid conclusion. If we instead like we start having like completely random results, and so we have that in some measurement it works, in some measurement it doesn't work, then probably is not a good conclusion. This eventually might have some, like it needs to, some way it will change the way we make conclusions, because now we are in a situation where we always can say if someone or something is better than something else. So we can always compare. If we start having like this multidimensionality, we lose this power of comparing things, because you can have that someone is better in some measurement, but is worse in other measurements. But I would say that this loss of power actually comes with actually having more knowledge of what we're doing, because at the moment we can always compare things, but we're not comparing them on what we think we're comparing. So it's just fake knowledge pretty much. So yeah, with that said, thank you very much for your attention, and yeah.
Okay, so we have 5 minutes for last question. I sometimes show a graph that basically illustrates that data volume increases faster than processing power. And I think this is really important when it comes to making sense of data, because you're limited. You need to take decisions. What are the data to look at it now? And that really limits you in terms of what you can see, and there's a lot of dark data, and a lot of truths may be hidden in that dark data. Now things get even more concerning as people are now trying to create those digital twins. Not only this, it's not just about trying to get a picture of the world. You create feedback loops, you use it to control this world. But at the same time, it's now becoming visible through ChatGPT, for example, that even if you have a trillion parameters, a certain percentage of those are not correctly determined. And so it's going to mess up the system, but you don't know when and where. By the time you notice it's messing up the system, it's basically too late. I find your discussion interesting, but I think it would be good really to also show some real world examples of where those things have actually gone wrong. I would say, for example, during the COVID-19 pandemics and response measures, at that time, basically, we have switched to another notion of what constitutes evidence. In the past, evidence was determined by falsification or verification. You had to do experiments for that. At some point, data was declared to be evidence. And we're going away from validation, and calibration was basically considered good enough to have a good picture of the world. And then further on, politics was responding to forecasts. A situation that could happen, but was pretended to be, it would happen, but it never happened. Now, if you apply such a system to hospital capacities and triage, then basically you start killing people for facts that never happened. This is how bad it can get. I think, to really illustrate why those things matter, I would also add some more discussion around the recent world of big data and how that has changed basically the way of doing things and where this has gone wrong and why.
Yeah, I think it's some way like it. Here, I think it's important also to stress like at the very, because one of the problem is like if you try to show like this many times, people say like yes, but like models are imperfect. There is a lot of problems going on. So, and also, for example, if you, for example, the SAT score, I think it has very low correlation with actually success in life. But still, people use it because they think it's still a good measurement. It's not a good predictor, but still a good measurement. So there is still like this culture that still like our measurements are good. I think it's important to really to undermine the entire conception, to show that actually you don't know, like you need to prove it that your measurements are good. Because as you mentioned, like people even moved from validation to just calibration because some way like they really trust the measurement. And I think this is a good way. And yes, I think it's important also to show like all the implication, the political implication that this has, and what happens actually in real life when people start using this approach, because then they take fundamental decisions for the population and they might be based on pretty much nothing, almost by noise.
Yes, on the question.
Thanks a lot for the presentation. I enjoyed it because I like these things, right? It's wonderful. What we saw in the social science was the term replication.
Yes.
To replicate certain findings and it couldn't be replicated, right? And I found specifically with theories that were considered, only present, hierarchy of needs. I mean, one of the most repeated myths of social science has been completely debunked several times over, right? So on the one hand, but the way I understand your presentation is that specifically the source to be found, or the reason for finding this problem might be in sort of what I might term now liberally the measurement freedom source. But I think there might be more factors that one can contribute it or attribute it to. One factor, and I'd like you to reflect on how they kind of could feature in your presentation. One factor could be Nassim Taleb did an interesting thought experiment. Say, okay, well, let's apply the normal distribution on income, right? We find that those outliers that we usually would disregard in the social sciences, the Bill Gates, so to speak, we would disregard them, whereas they are the most important factors, right? The outliers are the actual interesting data points because they determine a lot in the social reality. So he proposes then a different kind of logarithmic approach to those things and even a fractal approach. But okay, be that as it may, I think there is another problem associated with that, and that is this idea that social reality. And that is an idea that started at the end of the 19th century. Social reality and social science needs to make use of the tools of 19th century physics, apply a mechanistic view of the world, and hence we can also use the mathematical tools that physics is using on the social in order to make us more scientific. I think there is also a fundamental problem in just a very late age, how we try to capture the world to say cool knowledge which we want, and that doesn't square with social reality.
Yeah. No, actually. So there is a little, like, I can address some of the points. The first thing is actually this is connected to the replication crisis, but some way, like, this is worse than the replication crisis, because if you try to replicate one experiment with the same measurement, you probably will get the same result. Because if we go back to this, actually, if someone replicates the same experiment, let's say like someone initially got this result, if someone replicates exactly the analysis, everything, they will get exactly the same result. So they will say like, oh, this is perfect. There is no problem here. The problem is some way if you're trying to replicate the measurement of the construct, but not the entire process. And the problem is people are not really aware of this because they think that actually we're accessing directly the construct. So I've seen paper, paradoxically, it's that if we have information of how the entire analysis is done, it's easier to replicate and it will look more solid, even if it is not. So some way we have a lot of the replication crisis because there was very little information. So instead of repeating the exact experiment, they had to go through another route. And so they say like everyone is testing the different routes, and then they say like, oh, it doesn't work. But with the new studies, everyone will follow exactly the same route because then they have to replicate the same experiment. And so this actually might generate a lot of confusion because we will have a new wave of studies will look like they're safe, some way like they're producing new knowledge, but actually they undergo the same effect of this one. And regarding, for example, the assumptions of normal distribution, all these things, yeah, actually there are many different ways, and like in data analysis, they love to explore many different ways to analyze data. So that this is also like a problem, like some way is also the other side of the problem. Everyone is testing different methods, and so like they would get different results. But yeah, I don't think that there are still people which think that, for example, for mini tests, you need to assume normal distribution. But if you look at the test, especially with big numbers, it doesn't even make sense. So I think there is a lot of misconception regarding statistics. But yeah, it's still a lot to explore. I don't know.
Yeah, thanks for the presentation. Very interesting. It's always refreshing to attend a presentation on meta science. I think we should do that more often. And I'm very sympathetic with the basic problem that you're raising, because it's something that I face also directly in my research. The problem basically of having accurate measurements of qualitatively rich concepts. Basically, what we do, for example, in neurophenomenology, is all about kind of striking the right balance within this problem. But it seems to me that your presentation could lead to two directions: a moderate and a radical solution. And I wonder which of the two you're opting for. So the moderate approach would be what we should reform the way we measure things, and probably we should reform the very notion of measurement. And the other one, which is the radical approach, would be we should get rid of measurements altogether. And I was curious to hear from you whether you believe that there can be a measurement-free science.
I really don't know. I'm more opting for the, let's say, smoother approach, and I think like we should really reform. I don't know if it would be possible. Like, there is qualitative, which some way like it's already going in that direction. Still, people really like measurements, and also it's, for example, if you want to make a more complex model, you need some degree of quantitative to actually make, for example, predictions. So it's technically, well, you already have qualitative, so it's technically possible to make it like a measurement-free science, but some way like people really like the measurement science. So I would push more, and this is actually what I'm pushing, to try to spread awareness of like the fact that we need some way to reconceptualize measurements. There is scattered work about this, and this is also kind of paradoxical, because some of these things have been known for almost 100 years. But yeah, I think like we really need to go back to that work and try to reconceptualize measurement.
One last question, Doc.
Yeah, I want to reiterate that point that there are many important qualities that are not quantitatively measurable, but really matter for people, like friendship, love, creativity, freedom, and these kind of things. And as we basically do more and more what is measurable and put that in the foreground, we basically push the qualities into the background. Even if we would live in a fully quantifiable world, but that world could be NP hard, and we try to make it computable by approximating it by not NP hard algorithms, some heuristics that simplify things, basically how to make them computable in a reasonable time. That would already throw away a lot of good solutions. And do we really want to live in a fully computable world? It basically eradicates qualities that we like, which are really important for our life. I don't see much discussion about it. I've seen Margot address it in her oral lecture, those non-quantifiable things that matter. I think we should put them more into the foreground, because a lot of engineers are just not aware of them. I think they're doing a good job by making ever more things quantifiable and realistically based, but it may be a totally wrong track. So I don't think we should abandon measurement altogether, but too much measurement, I think, is eliminating opportunities that make life worth living.